Hello, Farmington High School. This is Mr. Hoover speaking. Trying to get us some Unit 2 Notes 1. That's the first time I've said that this year. Graphing system of equations. Here's the deal, guys. If we don't know how to graph yet, we gotta go back to the drawing board. All right, you gotta come ask some questions. You gotta get comfortable with it sooner rather than later, because now we gotta use all of those. Okay, so let's practice graphing then. Write down, graph the two linear equations on the same coordinate plane. All right, I'm going to go down to -5. That's my y-intercept. That's why it's written last here. So I'm at -5, and I'm going to go up 3. So up 3 over 1, up 3 over 1, up 3 over 1. All right. That might be the straightest line of the year. Maybe not. All right. My second one is a +2. So you guys know that I'm looking at this +2, and then this is what I count. And remember, it's rise over run. So I find +2 up here. That's my y-intercept. Now it's -1, so I go down 1 over 2. Down 1 over 2, down 1 over 2, down 1 over 2. You get the gist of it. That's not a straight line. But here's what I needed to see. In this line, write down everything you notice about the two lines. They intersect at one point. Okay, that point you should be able to see is right here. I would say that's 2, 1. Okay, that's going to become important later. Second one, graph the two linear equations on the same coordinate plane. The only one thing they did here is they made this standard form. So that was ax plus by form equals c. If you don't remember that, that goes to 0. This is a -2 here. -2y equals -6x plus 12. Remember, this is a plus here. I would just divide by -2, divide by -2. One thing I do is I put a slash through the negatives to know that I made two negatives equal positive. Divide by -2. So I'm going to have y equals 3x minus 6. So -6, I'll just graph the standard form one. It's right here, up 3 over 1. Okay, remember any number can be written with a 1 underneath. I think it's a shirt. Shirt doesn't let me draw a straight line. So this would be rise 3 over 1. Then the first one was y equals 3x minus 6. If you're thinking I made a mistake right now, I didn't. I was going to tell you I did, but I actually didn't. Here's what I wanted you to see. If I graph that one as well, it's going to be the same line, right? We ended up with two results here that are exactly the same. So they're going to be graphed the same. That makes sense. What do you notice about the two lines? Same lines. The graph is on top of each other. Something like that. They graph each other, I don't know, whatever, something. Alright, so let's talk about what we're learning today. Systems of linear equations. What is a system of linear equations? So that box that has system of linear equations, in the middle box, we want to write a system is two or more linear equations. This two or more is the key part. Alright, they could give you a bunch of different ones. It doesn't always have to be two. Then the last part, the solution to a system is the point xy where the two lines cross. The solution is where the two lines cross, where they intersect. They use this intersection word a lot. Where they intersect. Good thing I'm a math teacher, not in English. Next, there are three different types of solutions. Alright, so here's we got one. So there's a box there. One solution, point of intersection. Okay. These are going to be different slope. So different slope. You can see one's positive and one's negative, and different y-intercepts. Okay, when they have different slopes, different y-intercepts, it's going to be one solution guaranteed. For this one, no solution, parallel lines. If some of you can remember, parallel lines have the same slope. You can see here, they have different y-intercepts. So diff y-intercepts. Now, the last one is going to be infinite mini solutions, same line. So this is the one we just did. They didn't do a very good job of showing you two lines, kind of. But they're going to have same slope, same y-intercept. And yeah, on your quizzes, papers, practice, whatever, you can just put one line, that's fine. But make a note. Tell me it's the same line, whatever it makes, so I know that you know that they're on top of each other. Uh-oh. Took a while there. So steps to graphing system of linear equations. 1, graph the first line. So I'm going to graph that first line. 2, I'm going to graph that second line. Then I should have an idea. Could they be parallel? Could it be one solution, or could it be infinite? 2 is going to be infinite. It's going to stick out like a sore thumb if they overlap each other. Excuse me. Find the order pair where they intersect. So that is something you're going to do by graphing. And then this is, if they are parallel lines, no solutions. They're not going to intersect. If they're on the same line, infinite mini solutions, or they overlap. So we're going to flip over to the back. We're going to solve system by graph, blah, blah, blah. Solve systems by graphing. It is as simple as graphing each equation, then finding the points where they cross. So I'm going to try this. Who knows if I'll make a mistake. So positive 8 is up here, positive 8, down 1 over 1. So I always think of down 1 over 1. Okay. I like how I blame the shirt for the reason I can't draw a straight line. That's pretty clever. If everybody finishes early, we'll have a drawing straight lines contest. Now the second one, negative 7. Down here, up 4. It's a positive 4, right? Yep. Up 4 over 1. Up 4 over 1. Uh-oh. I think they're going to cross. Winner, winner, chicken dinner. Now, we want to solve it. So right here, put my little black dot. 3 and 5. So 3, 5 is what I got. Move my answer thing. 3, 5 is what they got. Okay, that's how simple it can be sometimes. Let's try the next one. I won't even have to technically do the problem. Here we'll do it anyways. Positive 6, positive 1 are the intercepts. They're both down 1 over 2. And when I say I won't even have to graph it, what do I mean by that? You should be able to look at this and tell them these are the same slopes. So if you flip over to the front, the pictures, it says same slopes, different y-intercepts. These are same slopes, different y-intercepts. But if I was doing this by graphing and I didn't recognize that right away, you should still be able to see. You'll know when we assign a problem, you'll be able to tell if it intersects or not. And I can see they're parallel, so what's the answer? There's no solution because they're never going to intersect. Alright, so if they're never going to intersect, it's no solution. Ooh, and we will throw in a word problem. This is probably going to take the longest part of this. Alright, Monica and Max Gordon each want to buy a scooter. Monica already saved $25. So, $25 and plans to save $5 per week, and that's Monica. Max has 16 and plans to save 8 per week. One thing, reading the quizzes, per week. Strong, strong, strong indicator. X equals number of weeks. So, first thing I need to do is I need to write 2 equations for this. So for Monica, I got in red. So Monica, her equation is going to be y equals. Now what is y equal? How much does she save per week? Well, she saves 5x. How much did she start with? Or what's my y-intercept? It's 25. So then Max is going to be a little bit different. Max here, he's like me, he spends his money. So he's going to start at 16. But he has the option to save a little bit more. So he's going $8 per week. So your y-intercept is always what you start with and then how you're going to change. So let me graph these a little bit, but I need to do something. X is number of weeks here. So I'm going to go by, this is 1, 2. So every 2 is going to be number of weeks. So this would be 5 out here, and this would be 6, 8, 10. So I know there's 20 of them. Let's over here go by, if I know the answer, and I'm trying to think right now. It's too much. Let's just do everyone is 5. So I'll do 5, 10. All right, this is 20. This is 30. This is 40. This is 50. Awesome sauce. All right, now let's graph. I start with Monica at 25, so that's easy. Right here, 25. Every week I go up 5. So up 1 week, so I'm going to start from my 1, and I'm going to go up 5. This is awesome. Monica works out perfect. So I'm going up a week, so I go over 2, and I'm going up 5, which is up 2. So Monica worked out perfect for me. Let's see about Max. Max is goofy, though. He starts at 16, so 15 just on top of it would be 16, and I'm going up 8. So now I'm at 24 after a week. So that should be about here. Then after 2 weeks, I'd be at about 32. If you don't know where I'm getting these values to, they're kind of in my head, but they're also, you should be able to plug in 3 and get that. So it looks like 4 is 48. So blue is going this way. So now what I would do, I would go like this. This is 3. All right, so I go up from 3, and it looks like it's about 40. One thing you could do is you could plug X in for 3. Plug it in here and plug it in here. 5 times 3 plus 25 is equal to 15 plus 25, which is equal to 40. 8 times 3 plus 16, 24 plus 16, that equals 40. So I did do it right. When both of them are at x equals 3, they both equal 40. So that's definitely my point of intersection. Now to answer the questions. And how many weeks will Monica and Max have saved the same amount of money? So this is money here. This is weeks. Well, it was 3. So 3 weeks. And you guys are obviously writing sentences on your paper. I just ran out of room, so I get the get out of free jail card. All right, then how much will each person have saved at that time? I got you guys. They will have saved at that time $40. Done. Okay, that's a word problem that's going to take a little bit of time, but good thing I'm flying through this. Solving by graphing. Let's keep going. All right, the only thing they did here is they didn't put it in standard form for it, or they gave us standard form. We got to put it in slope intercept, because otherwise I don't know how to graph very well if I don't have slope intercept. Goes -4. All right, I'm going to subtract -2 minus 2x. So this one is over here. All right, is minus 2x minus 4. Now this one down here, 5x minus 5x This goes to 0. 3y equals negative 5x minus 6. Awesome sauce. Negative 5/3 x minus 2. So I'm going to do this one in red. Minus 4. And then it's down 2 over 1. So I'm going to draw nice and neat here. This might be the first interview in the video in about, what, a week and a half that we don't get interrupted in. Awesome. Alright. Negative 2. Negative 2 is right here. So this is going to go down 5 over 3. So, oops, I went down an extra one. I still can't count. 1, 2, 3, 4, 5. So this is over here. So these guys are really close to each other. So up 5 over 3. Uh-oh. Up 5 over 3. Okay. So at the beginning of it, I told you that we will show you that they will intersect or be close to intersecting. This is about as difficult as it gets. What I mean by that is these are running so close to each other, you don't see that they actually intersect until right here. Okay, so for me, that's 8, and then down here is negative 6. Let's see how I did. Wow, I made a mistake. Your math teacher should not be able to do that, but look at that. I gotta count x over first. Negative 6, comma y. Hey, I flipped things up too. It must be the case of a Friday. So that's one of the more difficult problems because it's hard to tell by graphing. I actually did this one using algebra, but we'll show you that in a little bit. This last one here, this is not standard form. Notice that's a negative, so it doesn't count. But I got to redo it. So negative 4x plus 2y equals negative 8. I'm going to add 4x to both sides. Notice there you can write 2y equals 4x minus 8. Divide by 2. Notice how nice and easy I wrote divide by 2 on all of them real quick. So I got y equals 2x minus 4. I want to go home on a Friday. Moral of the story is, just count up 2 over 1 every time. I don't know where these intersect at, so we're just going to keep going. Actually, look at this. Y equals 2x minus 4. Where do they intersect at? They don't. Okay? They overlap. Look at that. I drew some Christmas colors because that's my favorite. Now, if they overlap, that means infinite many solutions. Voila. What does that answer? Bounce. Sweet. All right. That's what I got for you today. Hopefully that makes a lot of sense. If you're still having trouble graphing these on your own, that's going to be a problem. On the practice sheet, make sure that you graph them all by yourself and then go and check those graphs. Don't just check the answer. Make sure you're doing the work correctly. Thanks for paying attention. I'm going to hit that. Stop.